All right. Welcome, everyone. Good morning, good afternoon, good evening, wherever you are joining us from. I'm Jenny DeFigueredo, the Community Manager for DVC. Today, I'm excited to have Beth Rudden, CEO of Bast AI, with us, as well as their CTO. Beth Rudden is an established IT leader with expertise in digital transformation and cognitive science. She founded Bast AI in 2022 to democratize ethical AI. She is recognized as a top AI ethics leader with a successful track record transforming AI and analytics into a $2 billion venture. Beth holds degrees in anthropology and classics and is known for her comprehensive grasp of explainable AI. Her influence extends through her patents, literary works like AI for the Rest of Us, and inspirational speaking. Beyond her career, Beth is a dedicated educator, mother, wife, and esteemed advisor, actively shaping the future tech landscape. I'm really excited to have her here because they use DVC as a part of their solutions to a lot of great problems in the world and doing it in an ethical and explainable way. So I'm very excited to have both of them on today. They're going to show you how they do that and give some demos about how that's done. So with that, take it away.
Hi, Jenny. Thank you so much for having me. And it's a pleasure to introduce my CTO, Tan Lam. And Tan, if you want to say a couple words and just introduce yourself.
Yeah, hi, this is Tan Lam. I'm a CTO of Bast AI, and I've been working with Beth for like the last 20 years or so, and continue to build great technology with Beth, and very honored to be on this live stream.
Awesome. And then Jenny, if you can pull up the screen sharing, I'd like to do a little bit. So what I'm going to do today, and this is actually, I'm pulling from my technical deck. And I was super excited when Jenny asked me to do this because it's not often that we get to really talk about the technology that we're doing. So I put together an agenda today of what we're gonna really talk about, and I want to give you a little bit of an introduction to Bast, who we are, and what our timeline is, why we are different, and why versioning matters. I'm going to do a demo of a Medic Copilot that we built, as well as an ontology that we built for the Medic Copilot. And then I'm going to take you through some Gorpy solution architecture and talk through some principles that we have that we use in order to be able to really develop our software and our product. Then I'm also going to have Tan show us the data pipeline. Note, last time he did this from Legoland live in San Diego on his cellular. So we are very, very good at making sure that our hardware or our software is very robust. And then I'm going to show Jeannie Cat and take some questions. So with that, are you okay for me to go, Jenny?
Yep, go for it.
All right. So, let me talk a little bit about our timeline. So we founded Bast in October of 2022, really, very, very intentionally a couple months before we knew ChatGPT and GPT was going to come out. And this is something that Tan and I, had been playing around with. And then even before that, in the before times, prior to COVID and prior to ChatGPT coming out, we have been building AI systems using ontologies for, a very long time. And a lot of what ChatGPT did for us is in 2022, the world started to understand what AI can do and really what generative AI can do. So one of the things that I teach, and just to ground people in the understanding, NLP has three phases or three things. You have natural language understanding, you have natural language classification or the prediction, and then you have natural language generation. Everything that came out in November of 2022 was all around this generation. And back in the day when we used to have like lots of the conversational AI or chatbots, we would have to go to our friends in IT and say, give me 50 variations of this question and give me 50 variations of this answer. And then we would have to put all of that together into a knowledge base in order to serve that up. And that was before generative AI really became popular. And what we had been doing is really focused on natural language understanding. And in order to understand, you have to understand against a context. So I'll show you what that means in a second. We did 8 pilots in 2023, and we ran around trying to see where and how we could really give our engine and make sure that our engine was able to show this explainable and predictable and ethical AI that we build. And then we launched our explainable AI engine at the beginning of this year, and we're going from pilots to repeatability, and we're exploring different use cases. So one of the very first use cases that I wanted to show, and this comes from a pilot that we did with a friend of ours, and he really became a friend because he found me when I was doing a particular podcast. And when I was doing this podcast, I really wanted to show that that I had been talking about like how we can give somebody a medic co-pilot in theater. And it was funny because I was talking about how we build AI that is so small that it could be used on a device and it was portable. And so we went into a pilot mode last year, and we developed a medic co-pilot that could be shipped to the tactical edge in theater. And he found me and he's like, hey, do you even know what medevacs are? And I was like, yeah, my husband's been a medevac pilot for 20 years. And it seemed like such kismet that he discovered me, and he was in the Denver area. And so what we did is we developed this conversational AI, and we call it a cat. And so with that cat, what we did is we pulled in the Pararescue Medical Handbook. And the Pararescue Medical Handbook was something that, sorry, I had to stop sharing for a second, was something that we ingested. And Tan's going to show you a little bit later how we do that type of ingestion. And so we call everything that we do a CAT, or a conversational AI technology. And we wanted to differentiate from bots because it's super important to make sure that everybody knows that this is a little bit different. This includes natural language understanding, natural language classification, and natural language generation. So when we ask the cat a question, and in this sense, I'm saying, hey, what do I do after this procedure? Well, this is number 4. So I give 5, 6, and 7, and then we get a picture of the page. And this is something that makes us very different because when we take the data in the data pipeline, we take a picture of every single page. And this is where DVC comes in. And we're using the data version control, or the data registry, in order to really show the picture of the page and be able to store this in a registry system. And then we say, this comes from the Pararescue Medical Operation, the 8th edition. Here's the author, and here's the reference that we pulled up. In addition to that, we show the context that we used in order to generate the response, and then we stored the context into an open search database that sits on our data version control registry. So this can be retrieved without internet connectivity. So why we did it this way is we needed to find something that we could ship to the tactical edge, find something that can have the levels of variation that we wanted to say, okay, we can interact with the data. In addition to doing this, we also built a way to have deterministic responses. And this is super important if you're a medic, or if you really want a response that is coming up every single time. So in this instance, I show here's something where I'm asking the same question every single time, and we get the same exact answer. And the reason we get the same exact answer is that we used an ontology, or a knowledge graph model, that we version in the data version control data registry. And we use these entities that map to the actual entities in the question that I asked. And we mapped it to this particular intent. So, and we did that using an expert and somebody who was an expert in the field. So we had a human in the loop map this so that we could get 100% accuracy. This is super important because if you need to learn a medical procedure, you typically need to learn that verbatim. And so you need to have the exact response with no variation be given every single time. And so this is how an example of how we do both deterministic responses, indeterministic responses, store those responses into a data registry system, and be able to retrieve those responses at any time. So what I'm going to do next is show. Let me go back to my agenda here. Is show a little bit more about how we're doing some of the solution architecture, and I want to talk through some of the principles that we have. And our technology principles are really based on using lightweight open source frameworks and mature programming languages. This is the best of both worlds. So we used a microservices framework, and microservices means many things to many people. In this instance, we are meaning it as small little jobs that we are pushing in, and that allows us to have composable and composability for our different jobs that need to be done. And then we have an open source library of dependencies, and this allows developers to choose only what they need to do. We're building applications as a service that communicate through APIs. We have automated our build, test, and deployment with our CI/CD pipeline. And then we use a fully managed service to implement complexity across application development and data management. So we use development containers to simplify runtime, and everything is containerized. The instrument end-to-end monitoring and tracking is all logged and has full traceability and applicability. And then we have like a defense in-depth approach to secure apps and data. And this is something that we can show you. Because we got to use data version control, we only show like a hash. So everything is fully encrypted. Everything's, totally stored in the cloud or physical storage. And this is something that we do very different with our full stack engine. And our engine, unlike APIs like from Cohere or Claude or ChatGPT or GPT APIs, we're actually including the infrastructure layer that's fully containerized that allows us to spread some of the load over Kubernetes clusters. We're also including a data management layer. So this is a full persistence layer. And this is where we have our data pipeline that allows you to take any bit of your data and be able to enrich it using any LLM and then push it back into a fully versioned system of record. And that data management layer is something that allows you to see how the models are being trained and how the feedback mechanism works and how the system is laying down the data and why the system is predicting the output or the classification or the prediction that it's predicting during the interaction with the user intents. And then we have an orchestration layer for all of our APIs. And then we have webhooks for our front end experience and integration. So we can hook into any single front end. What I wanted to show is some of the overall solution architecture. And what we are good at is we're giving people an engine to be able to take all of their unstructured data and be able to interact with it using our APIs or our pre-built application interfaces. We can use any generative AI or LLM for enrichment, and we operate and it's designed as a container, again, for portability and for the ability to use different types of systems and be able to hook into different front ends and to be able to be embedded in different applications. And what we do a lot of is understand how to pre-process and process the data with full lineage and provenance of the system. And the reason that we're able to do this and the reason that we have explainability is we don't use black box artificial intelligence in order to do the prediction. We only use the LLM to be able to enrich your data that you already have. So when your data comes into this data registry system, and this is the framework that we use from DVC, your data goes into raw, to staging, to processed, to our models that include things like ontologies that extract the entities and the relationships. And then into the configuration, you can interact with your data through Jupyter Labs and Jupyter Notebooks. And then all of our pipelines are able to call any one of the AI large language models or small language models or any language model that you would like to use to enrich your data. And then all of this is something that we can push into a container and embed into your application. So, Tan, do you want to say anything about our overall solution architecture before we move on?
I'm sorry, I was on mute. So
Nope.
yeah, no, the best. So you cover it very well. I mean, one of the things that I would like to point it out. DVC is like the back end of our data store for unstructured analytics, or for all of the unstructured data, including the raw data to until the staging and processing. The way we process, we're gonna create a huge amount of like different data from the unstructured file, number of file, number of picture, number of those, using DVC to manage them. It just reduce a lot of headache when you having some conflict from different people, different developer on how to manage those systems.
Yeah, that's actually a really good point. One of the things that I missed on my agenda, because I got so excited wanting to show you what we're doing, is the importance of data versioning. And so I asked ChatGPT here, the importance of data versioning in the context of our AI technology. And one of the things that I wanted to point out here is that you can have the reproducibility. So using DVC allows us to have a healthcare application that can not only predict patient outcomes, but by versioning the data, you can ensure the exact data set used in the training phase can be retrieved for testing, updates, or audits. This gives us a test-retest reliability to ensure that the data system is reproducing every single time. And this gives you the ability to predict based on things like abductive inference or logic or reasoning that can persist into a graph model or concept hierarchy. It gives us full traceability and full accountability. So let's say a financial institution needs to use the AI engine to detect fraudulent transactions. And then if a mistake is made, versioning allows you to trace back to the exact data set and the exact model that was used at the time of the decision. The traceability helps in diagnosing the issue, but also provides a clear audit trail. It allows for the collaborative development. And I know, Tan, you look at this a lot, where you have multiple teams working on multiple aspects of an AI project. We have versioned for every single data object that we put forth, just like we showed in our solution architecture. So we can have a human expert working on an ontology, where then you would have another developer working on a data pipeline. And it all works because you have that data version control, ensuring collaborative development. You can also manage data evolution. So taking data from a raw state to a transformed state, you have disaster recovery and rollback, you have full data integrity. DVC gives us so much. So hopefully you guys hear that we're really excited about using the data version control and the data registry, this amazing open source framework that is underneath GitHub, and it's something that we use very often. Next, what I'd like
I
to
wanted
do.
to pop in and say, yay, amen.
Yay.
Good job. It's so beautiful to see.
Tan, I would love for you to share your screen. And if you can please show what we'd like to do is we're going to run the data pipeline live. And he's going to run it using the book that I wrote called AI for the Rest of Us. And that was something that was released in 2023. And a work that my co-author and I did in order to be able to ensure the world knew that there is a different alternative way to use artificial intelligence to be able to show your work and have full explainability and lineage and provenance when you use systems like DVC. So with that, Tan?
Yes. So what I'm showing you right now, this is the we have the demo registry, DVC. This is what I'm calling the client data registry. We use it a lot for demoing our pipeline purpose. And then I also, create a code space in GitHub. So I just want to show you what it looked like in GitHub and what it looked like inside my development environment using DVC. from the GitHub perspective, you will see we have the client data registry and data. We have ontology. You only have the DVC file, which is just the hash file of the real file in support in the back end, and then you will have draw data, staging data, just like Beth was mentioning. DevCat is just a DVC minute version control, and then we have staging, we have process. However, it looked very simple from the GitHub perspective. When I open up this project under my container in code space, actually underneath, all the data, you will see when I do the polling, you will see, the DevCat, I have the Excel file, PDF, text folder, and in the process, I have, DevCat, I have contact, QA, and all the book. So let's beginning with, like try to remove this data first, and let regenerate this one from scratch. Let me see if I can delete this. I can delete this. I can delete the book. I'm just generate this, like some of this earlier. Okay, so our pipeline, we have the pipeline we're using Python, and then we are going to. I just want to quickly run the -it to show you the number of pipeline we have. We have initial pipeline, we have intent, we have contact, we have QA pair, we have quiz question, we have convert PDF. It's just like one of the process, and all of them using microservices versioning control, like inside our private PYP, pipeline server. And for the DevCat, I just pop in the file called AI, for the rest of PDF file. This is the book that written by Beth, like this is the PDF version of it, 72 pages. And this is, what we call consider raw data underneath the source. So I'm gonna kick up the pipeline. Let me see if I can remove this part too, because this is the process of the PDF. So let's see if I want to kick up, like Python router converts PDF -c DevCat. What this pipeline will be doing is they will break the book from individual file, from a single file, into images. You can see the images, page 1, page 2, page 3. They continue to roll the images in, from the book. They extract the page into subpage PDF. They extract the text of the page. Like for example, this is page 13 or page 13, and we have we running faster than I expected to capture. So this is basically, like this is all the text that showing you on that, and along with the image we captured earlier. I mean, you can see from a single file, we actually break it down to, individual images, in the individual page text, and everything was controlled within DVC. So the first step we do is we break, like the book into subpage image, and we carry along the reference onto that. For example, let's say page number 3. This is the text of the page number 3. This is all the text inside page number 3. This is the information from the article, author, PDF book, and this is coming from the reference on the page number 3 image. Moreover, we also include in the next pipeline we call generate contact. So now we have all the text from the book. We would like to call generate contact. This is where we have the generative AI jump in and then go in some to work on it. So all the text that we extract from the book, we are going to process them to generative AI to generate context. So we have the generate context will actually similar to what we do. We build up the JSON file with like the vector embedded database of page 1 PDF and all the individual reference to where we got the text information from. Along with we carry the text version of those. So this is the context on the page number 3 we have, and this is all the information along with the context we have. I mean, we can also do in the next step by, okay, now you have a context. You know, what can you do with the context? So we have generate quiz question and generate QA pair. I mean, let's take a look. If I just try to, initially do the first 9 page of the book instead of doing all of them. So let me remove some of this so I can show you. I just want to make sure, we have enough to show the entire end-to-end pipeline.
I think they get the point. And Tian, it's probably running faster because you're not at Legoland in San Diego, streaming your system.
We can generate quiz question. And generate quiz question, the idea of quiz question is now you have the context of the book or the text. What question you can ask about the book? Okay, maybe I did some of this in there already. Let's take a quick look. Oh, it just remove everything. Yeah.
We've come a long way from having to ask humans to be able to do different quiz questions and to do different variations.
Yeah.
So Tan, let me take it, and I'm going to show them what this looks like on the front end, because the point of everything that we're really putting together here is that we want people to see the entire process of how AI systems are actually working. And, the ability to show your work is something that we can do. So in this instance, this is a genie cat that we created against the book using all of that processing that Tan just showed you. And one of my favorite questions that I like to show is, what are humans good at? And the reason that I like to show this one is it gives this understanding. Humans are good at intuition and emotional IQ and common sense and creativity and specificity. And then it brings up the exact page from the book, and it's in this like little diagram that we did. Next, if we say, what a genie cat, what are machines good at? And machines are good at probabilities and analyzing big amounts of data and performing repetitive tasks and being objective and sensitivity. And the thing that I have also is I have this enabled for my ID. And this is where what we've done is we've generated the answer using some of the generative AI variations within the context window. And then we've stored that answer, and then we can just retrieve it. This is something where we can use our engine to create very quickly domain specific and book specific and multimodal specific information that people can use and interrogate. And for us, this makes this tool very useful. And probably one of my favorite questions that I'm going to retrieve from the book is a quote that my friend Dawn Ahukana told me once. And she says, essentially all models are wrong, but some are useful. And this comes from George E. Box, and this is his famous quote. And so it's very interesting that we can retrieve this very specific thing at this very specific time, especially in order to display all of the different things that are in the book. And then we can also obviously put this into a container, ship it to the tactical edge. And this is why we are so excited. And we love the fact that we've been able to use DVC, and that Jenny has had us on in order to really showcase this. So
this is amazing. This is like definitely, we've moved to the next level here. This is very cool to see. I'm very excited that you've used DVC to do it. So that's really amazing. We don't have any questions yet, but yes, audience, open for questions now. If you would like to if you have any that you'd like me to show them. But I do have some. I mean, first of all, I just think this is very fascinating. I was just talking yesterday. I had this very cool conversation with the director of the Center for AI Policy, and we were talking about some of all of the issues and what needs to happen and how the industry seems not willing to, self-regulate on these things, but it's really wonderful to see like a company like you guys is like attacking this problem and going for it, and and being responsible about how to do their data and applying it to all these industries that absolutely cannot deal with these hallucinations. It's not going to work for medical data. It's not going to work for these things. And you're finding the answers, and you're really working that hard problem, which I just find very admirable. And thank you. So, but yeah, maybe you could explain like what, in what ways can Bast AI be best customized to meet specific needs of specific industries? Like, in what industries? Obviously, I mean, healthcare is one, but like, what industries are you seeing that are, prime for this absolute need of having this type of excellence and control?
So, anybody who is working with their hands, they're not going to be automated by AI. I totally disagree that we're going to have robot automatons that are around us all the time. And if we, take, I'm a Kai-Fu Lee is a leader who has a TED Talk out, and he's written a book. And the way that I definitely see what's happening too is that we are liberating. We are freeing we are taking the robot out of the human. So any of these repeatable tasks that have to be done, we can augment the caregivers, the medics, the nurses, the construction workers, the manufacturers, the people who are working with their hands, and helping to provide for this care economy, as Kai-Fu Lee says. And imagine if we are freed up from doing some of the things that we need to do, like, and I often look at it as like the early GPS, where we used to travel across country all the time, and we would have these triptychs that you had to go to AAA, you had to go to the actual office, and you said, I want to go from Florida to California, give me a book with a map on it. And the book, it was a physical book, and it had like the maps that you had to flick. And then you had to look around and say, okay, well, here's the largest ball of yarn, or all the kinds of things that you could see along the way. Right. Now we have GPS that does that for us. So why not have conversational AI where you can ask your question in natural language and have the AI be able to give you the response that you need, even pulling up a picture of the diagram or the blueprint or the building codes, or the simulation video of what the output could look like. Imagine engineers having this at the tip of their fingers so that they can use far more precise understanding of how to apply something that they can retrieve the right information for them for the right time. And so I imagine that this is something, and we are working furiously. We have a new partner, and I'd be happy to showcase some of this stuff, where we are working with a company called Career Highways. And Career Highways is just this amazing front end. They have over 200,000 users. They're adding 5,000 users a month. And they are really trying to upskill and reskill 16 to 26-year-olds in the Chicago to Wisconsin area. And they're matching jobs for what skills people have. And these are people who are in underserved communities, who might be going into retail jobs, might go into manufacturing jobs, vocational jobs. Mm-hmm. And this is where we're using Career Highways as a front end. Our back end APIs are there, and it's really interesting. We have this great relationship with the CEO, and she uses it every day. Like, what certifications can I take for networking? And their cat replies, well, here's all of the network certifications that you can take. And then we, give the exact point at where they are in their website. And we are able to do this and be able to use our ability to generate, these ontologies that give you the language of how systems are classified, and then allow people to understand how their skills in their language relate to the language of the job that they need to get. And this is where I think it's opening up such a huge world where we're giving everybody Rosetta Stones, and we're using artificial intelligence for what it's good at, which is translation and generation of the variations. Like this is the thing that I wake up every day and I'm like, we could change how AI is being used. We don't need to have these large language models predicting the answer, but we can use these large language models to generate the variations of the answers based on the true sources of information. And those true sources of information, we should carry full attribution. Because when we show where we get our data from, we're giving homage, we're giving credence. We're saying, hey, this is something that's important. It should have a verifiable source.
Definitely.
It should have a way to show that I really love George E. Box that came from my friend Don Ahukana. Like, I love that quote. I want to give reference to who said that quote first, and I want to show my work.
Right.
And that's how you develop trust, how you scale adoption, how you give people the understanding that they can use these tools in order to show the same thing every single time, so you can rely on it. You have control over it.
Awesome. That's fantastic. I do have drilling down into a question from the audience, which is a little more technical, but this one came up. What was the hardest thing for you about using DVC?
I could take this question, Beth, if you don't mind. So, I mean, the hardest thing about using DVC, I mean, I'm not saying that it's not about DVC. It's about communication with your team, about collaboration. When we're using DVC, I kept talking to my team, to the people who were working with, say, when you produce some data, please commit into DVC so other people can, work on that data. They can commit into it. The more you hold on to it, the longer you not commit into the version control, the harder will be when we resolve any conflict. So it's about communication between the team, about collaboration. When you have this good stopping point, always done your commit back into DVC so other people can review it, can using it. Don't be afraid that there's some error in your data, there's some issue in the data. We have version control. We can roll back previous version if we need to. But don't be afraid of commit your data back into the version control system so we can have other people take a look. The farther you go along with not committing in, and the farther other people working on not committing in, they will create conflict in DVC. And when there are conflict and figure out what to merge conflict, that is a very, very difficult part.
And do you follow up to that one, when you're setting up these guidelines or templates or a rubric for committing your data, like is that stay consistent across projects that you do, or does it depend on the type of project that you do? Can you elaborate on that?
So it is very consistent throughout the project many different projects that we do. We have the practice for development practice, make sure, like just very standard practice when you say, make sure when you write code, you have a unit test. When you produce data, when you're done producing data, make sure you commit into the version control. And then, if you're committing in, you're always making, all the commit message say, this is what you're changing for the data set. So the other people can review the commit message, I know what it look like. So very consistent. The standard development practice and processes we apply for many projects, not just one.
And if you think about like in the real world, and this example comes from ChatGPT, mind you, but like in the real world, using like a construction project as an example, you have all the architects and the engineers and the contractors, and they're all working on a project simultaneously. And so they all need the current version of the blueprints, the materials, the data, the construction schedules. And then if a structural design needs to be revised due to all the unforeseen things that happen all the time, versioning ensures that all the stakeholders are notified. So, what Tan just said about communication is DVC enables good hygiene, good communication, good ability for everybody to work off of the latest version. And think of that in complex supply chains or in, provenance for manufacturing to make sure that your specification is matching what is actually coming out in the physical world. So this to me is something, back in the day when we used to create information systems and we used to create multi-dimensional data warehouses, and we would have like a VP come down and say, why was this SLA, 99%? Give me the information behind it. I want that to be 100%. And you'd have to go back and you'd have to have version data to make sure that you could give him that answer with specificity, with here are the actual data elements that made up 99. This is why we can't have 100%. We have to have that ability to go back and give the answer to what data set we used in order to get the prediction. That ensures lineage and provenance. It ensures reproducibility. It gives you the authority and the accountability to do it. I try to not I love that you are asking all these questions, Jenny, and I love the ability to talk about this because this is the meaty, gorpy stuff that happens in business and in life. And if we don't have proper version control, if we don't know how to sanitize all of the data that goes into a system, we can never have any control or assurance on the output. So if you sanitize the inputs and you're understanding what you're putting in, you can control what you get out. And that is what we think is so incredible about the technology that we're doing, is that we're able to have your cake and eat it too. You can have the indeterministic alongside the deterministic. And it's all because we understand how to properly understand our data and version it correctly.
Awesome. So I have another Gorpy question, an in-depth question for you that came from Sammy. I don't know why I can't pull it through on here, but he asked, can you speak a little about the trade-offs of full versioning, like storage space, garbage collection, etc.? Like, how do you handle that?
So, I mean, versioning helps with efficient data management because you really get rid of your bloat very quickly. And, the thing I remember about building data warehouses is you have to have an archive policy. And like, if you set it up and you design it in, then you are, you're giving the ability to archive specifically and offload that to a different system in a way that you'll never be able to do unless you do have the versions. So when we talk about the ability to build out, conversational AIs for things that you can be shipped to the tactical edge, that does not need to carry all the versions, right? You're only going to use the latest version, and you're going to have a mechanism in your code to make sure that all of the other stuff does not need to hit that storage facility. So in so many ways, this enables good hygiene for archival policies, for data bloat, for managing, your remote storage and then being able to pull them on demand. And it allows you to have the understanding of, who put that data where and when. And that's such an important thing, especially for auditability. And one of the things that we were doing with the Medic Copilot is really reducing the cognitive load. So that medic, using the Medic Copilot, they automatically have an audit record of every decision made. So they do not need to go back and relive everything. They have the ability and the assurance to know that that's all being kept for them. And then that can be processed in different ways to be able to learn how to do better in the future. But that's something that if you think about, like, the efficient data management that comes from making sure that you're bagging and tagging and versioning your data from the beginning. So it's all about, like, do the work up front, take the hard road to easy. Don't take the easy road to hard. That sucks.
That's the Twitter bite that needs to go out. Exactly. Right there.
And also, like when you classify your data into, like, critical data or operational data and, like transactional data, depending on your data classification, you should set your data policy, retention policy. So what we did very well, we put in, like Beth was mentioning, like different data set, they have different data retention policy. Some of the data, critical data, you don't want to lose it, so you can have, like archive and everything. Some of the data, we can just set the retention policy into 30 days, older than that, it can be clean now and collect.
Mhm. Cool. So let me ask another couple questions here. How does, you've explained this a little in your presentation, but how does Bast AI ensure transparency and explainability in AI-driven decisions, especially in regulated industries like healthcare and finance? I mean, we've talked about that with what's happening there in Medic, but I would really like to go over that because this is so important in these industries and others, but especially these.
So I think I got a little excited and I didn't show this. So I really want to show this now. And the ability to ensure the lineage and provenance is because we are taking data that you own and then laying that down in a system of record. And then we are, parsing it and classifying it in the way that you can retrieve it.
Mm-hmm.
In addition to that, we're also creating something called an ontology, which is a formal graph model. And we use another open source standard for that, which is the W3C standard that dates all the way back to Tim Berners-Lee and the advent of the World Wide Web, or WWW, so W3C standard. So this ontology is against that Medic copilot that I just told you about. And we are using the ability to use different entities and their relationships in order to ensure that these have logical relationships. And we use abductive inference, which is a fancy way of saying logic, to know for certain that an abdomen is part of your torso. Your torso is part of your anatomy. You have the ability to say, here, let me clear this for a second. Like, I always like looking at the word
Hey, Beth,
trauma.
share your screen yet, Beth?
Oh,
yeah,
so sorry.
Here.
I'm sorry.
Go ahead.
Oh, am I sharing?
Right now, yes.
Yes. Okay. So apologies. So I was doing, let me do trauma. So an ontology is and this is a graphical representation of the ontology itself. And so this is, using the word trauma. I'm just searching for the word trauma. We know that like orthopedic trauma is part of blunt force trauma, which is a mechanism of injury. And this is where using concept hierarchies and using the understanding that something is a part of something else, this is how we ensure that we have full explainability to say, well, we pulled up the abdomen. We pulled up the acute abdomen procedure, and your abdomen is part of your torso, which is part of the anatomy. Or you have like a trauma protocol, which is part of the acute abdomen protocol. Now, these concept hierarchies are really easy for humans to change. And we can drag them and say, you know what? I want to put trauma protocol under person. And then the minute that I do that, then trauma protocol becomes part of a person. And this is where we can easily change how these concept hierarchies work. And this is fully explainable. You can literally see how something is a part of something else. And these ontologies that we build are maps of the unstructured data and maps of that system of record that we lay down with your data. So this allows you to use really, I call this like the original natural language understanding. This is stuff that we've been doing for 20 years in order to showcase that we can see different variations of different systems and different entities and then their relationships together. And then we can annotate these nodes. So like if we're looking for, just the word, if we're looking for the word abdomen, we can also say in like abdominal region or abdominal or stomach area or belly or abdominality. And this is how it acts as like a Rosetta Stone. So it can take your language, your understanding of what you call it, and then put it into play of what somebody else might call it. And then that map acts as the Rosetta Stone. So it says, you're asking about this, so it retrieved that. And why it retrieved that is because this is a synonym of that. And then that explainability is based on logic and reasoning. That's how we humans understand our own realities. And I could go on, but that's literally how we are doing it, and why we want so badly for the world to know that showing your work, showing how these systems are used in what we consider the right tool for the right problem, in order to be able to make AI a practical tool that everybody should be using.
Awesome. That was beautiful. And so that ontological map that we were looking at, that's part of the front end of what you guys are building too, so they can see that and ask in the cat, right?
Absolutely. And, full props, that tool is an open source tool called Protege.
Very cool.
But we build the data, the content.
Right.
We automate it to about 90%. And then we say, if you want certainty, you got to get a human expert in the loop to make sure this is a part of that. And then we can even test that against all the unstructured data to say, in what variation does this not come as a part of that?
Okay, cool. So I have one more question. What advantages does Bast AI offer in terms of efficiency and cost effectiveness compared to other AI solutions like Claude or Cohere?
So we are making use of the large language models, and we use our engine runs on a system that can call out to those large language models. We use, the ability to create, the ontologies and the models that we're doing. It takes, 1/1000th of the compute. And the ability to reuse something that's already out there, or create your own based on a very good ascertain exactly what data you're putting in. We're doing this in a very different way, and it uses so much less compute. And from our point of view, really using the tools in the way that they should be used in order to be able to get the user the information that they need. And this goes back to, we really established Bast based on 3 principles. All AI augments humans. So what user are you augmenting for what problem? So we're narrowing the field of data that we're processing and being very efficient with that. And then all data and insights belong to the creator. This runs on your system. This can run on your hardware. This is not something that we're using and utilizing. We're just giving you the fishing rod and the toolkit and teaching you how to fish. And then the third one is all systems are fully explainable and transparent, which I think we've hammered on today.
Very cool. So is there anything else that you would like to share that maybe you didn't think of or missed? Or I think you did an amazing job presenting everything, and I am so fascinated by everything that you're building there. Or any other use case, like when we had the tech rehearsal, you mentioned some things that were very interesting, but I was like, oh wow, that's really cool. Just like social things that you're helping with too, that I thought were great projects. But I don't know, maybe those are under wraps. So, but if there's anything else that you wanted to share, I just would like for you to do that if you wanted to.
I'm good. I would love for people to reach out if they
Great.
have more questions. We are going really fast. We are definitely looking to expand, and what we think of is we're starting a movement. We want people to understand that you can have fully explainable AI, especially if you use the right tool for the right problem. And you can start to understand a different way and see the world in different contexts. And that's sort of a teaser that I wanted to put out there, because I think that our world right now, we could really use an understanding of a different point of view in different contexts. And that's something that, our tool really enables.
Awesome.
Tian, did you have anything that you wanted to say?
No, I'm good. Thank you very much for having me, Beth and Jenny.
Very happy to have you. Well, I want to thank you both for being here today. This was an amazing presentation. It's amazing to see what you're building, and that you're building this responsible engine and doing AI in a responsible way. That brings great joy to me, and I'm very happy to have you on. I'll have you on every month if I can. This is fantastic, and thank you for also going into depth about how you do that, and from the technical side. I think that's extremely helpful to our community. So thank you so much for that. By all means, everybody reach out to Beth Rudden and Tan Lam at Bast AI. I'm sure you can find them on LinkedIn and other places. And, in our community, reach out to us in Discord. I had put links in YouTube. All of this will be available on YouTube, and I'll have things in the description there for you guys to have in the future. So thanks everyone for being here, and we'll see you next time.
Thanks for having us, Jenny.
Thank you.